As you can see from the header, it was asking what kind of bottom was in this outdoor hot water furnace, and it's a live bottom. Let me explain. This is looking at the side view of the hot water furnace, and in the bottom of the furnace I have a 5-inch channel, 12 inches apart, 12 inches, and it's 4 zones. So being 4 zones, that's 2, 4, 6, 7, 8 pieces of 5-inch channel by 60 inches long, because the hot water furnace is 5 foot deep and it's 4 foot wide. And on top of these channels, I have grates. So the bottom is completely covered with grates. It's a live bottom. There's nothing else there but grates for the wood to sit on. And just below these grates, I have these jet tubes. Blowing air up through the wood. And being 5 foot deep, I'm making the grates 1 foot long with 1-inch rebar. So 1 foot long grates, 5 foot deep, that's 5 grates every 4 feet. Every foot. So it's 4 feet, that's 5 times 4 is 20. So that's, excuse me, every foot is 2 pieces of angle iron, and at 5 feet, that's 10 pieces. So that makes 40 pieces of 3/8 by 1.5 angle iron that I need to lay on top of these 5-inch channels for the ashes to fall down into this bottom, which is a live bottom. That's the reason I call it a live bottom. And these 5-inch channels, they go to the depth of the bottom of the hot water furnace, and that's 8 pieces of 5-inch channel by 60 inches long. And these 3/8 by 1.5 by 1.5 angle iron is 12 inches long. I'm going to give details on the complete build of this outdoor hot water furnace. If anyone can go back to the beginning of my videos, they can pick all of these details out and put it all together, and they could build their own outdoor hot water furnace if they chose to, if they have welding and fabrication abilities. Our end goal, once we build this and prove it out, after do all the tests, we plan on maybe cutting kits out for people that want to assemble their own if they have welding fabrication abilities. And like I say, that's the reason I call it a live bottom, because the only thing there is just grates. They're 4 foot wide and 5 foot deep. Wood sitting on all the grates. Just cross section of the grate itself, with the grate being 12 by 12, and the 1-inch rebar is 10.5 inches long every 1 inch. So being 5 foot deep, that means it takes 30 1-inch rebar to fill one zone. There's 4 zones, so that would make it 120 1-inch rebar at 10.5 inches long to fit down in these angles here. That's a cross section. Looking at the end, this is a rebar. This is an angle. This is an angle. The rebar will be fit between the 2 angles, and the overall width will be 12 inches. And the reason this is 10.5, this is 3/8. Here's a top view looking down on the angle iron, and here's the lip sticking up, and the lip, there's a leg up and a leg out. This is looking at it with a leg up and a leg out. This is the rebar going across. It's 1-inch spacing. For the whole length of the 12 inches. This is not the scale, I don't have it drawn out. Anyway, if you'll watch all the videos and look at all my details, I'm going to detail every aspect of the build of this outside hot water furnace. And there again is approximately 700 components. So that's 120, that's 160, probably 170 pieces of that 700, plus where the two local welding and fab shops have given me enough metal 3/8 plate to build the bottom section. So that's a good start. Now we need to work on getting these smaller components. And like I say, that's 40 pieces of 3/8 inch by 1.5 by 1.5 angle by 12 inches long. There again, let me stress, if you go back and watch all of the videos, I'll be giving you details on it, each step of fabricating this outside hot water furnace. Well, my goal is to get all the components together so then fix up a work order, then send the work order out on the floor so this can be fab in maybe 2 to 3 weeks. Then we fill it up with wood and start running tests. And then there's 100 pieces of 1-inch rebar 10.5 inches long. And once again, that's 8 pieces of 5-inch channel by 60 inches long. That's what sits in the bottom of the furnace for the ash to fall down into. And like I was showing over there, I've got 1-inch pipe with holes drilled in them where they blow air straight up into the bottom of a burn zone, and then I have jets from both sides of the furnace blowing in from its side about 12 inches up. So you have air coming up and air coming in about a 12-inch zone. That'll be will be the burn zone. You control how high that burn zone gets by the amount of airflow, and we'll be checking all the airflow with a bolometer. If anyone has any questions or comments, please leave some comments, and I'd appreciate it if you would like, share, and subscribe. If you subscribe, you will be the first to get the next video that comes out with more details on how this outside hot water furnace is being built. Like I say, all these details, you can take them and run with them if you wanted to. I appreciate you if you help me a little bit on that, if you did. This is, I haven't seen this design anywhere else, so I'm anxious to get all these components together and get this built, so we can prove it out with running the airflow test, temperature test, plus I'll be having the barometric damper on the flue pipe, plus I'm using a barometric damper internally to control the damper airflow with a damper, with another barometric damper. I appreciate you listening to me once again, and I hope you're having a nice day, and thank you very much.